मित्रांनो, last lecture we discussed about the special theory of relativity and Lorentz transformation equations. हे बघा, आता ज्या प्रमाणात गव्हर्नमेंटने आणि विद्यापीठाने आपल्याला सूचित केलेलं आहे की ऑफलाईन आता आपण क्लासेस घ्यायचे आणि त्यासाठी वॅक्सिनेशन हे जरुरी आहे. मग तुम्ही सुद्धा ऑफलाईन आता यायला लागायचं, वॅक्सिनेशन करून घ्यायचं. कारण ऑफलाईन शिकण्यातली जी मजा आहे, ऑफलाईनचं जे अंडरस्टँडिंग आहे, याला पर्याय नाही. ही साधारण 1.5-2 वर्षातली जे ऑनलाईन चालू होतं, हे शिक्षण थांबू नये, त्याला काहीतरी पर्यायाने सुरुवात असावी, त्यासाठीचा तो एक प्रयत्न. आणि त्याच्यामुळे आता ज्या प्रमाणात आपण ऑफलाईन मोडमध्ये येऊ, त्या प्रमाणात आपल्याला अंडरस्टँडिंगमध्ये हा फरक जाणवेलच. आता यापुढे येणाऱ्या परीक्षा सुद्धा ह्या ऑफलाईनच होतील आणि यासाठी म्हणून आपण तयारी करायची आणि कसं यायचं. मित्रांनो, ह्या लेक्चरमध्ये हम लोग देखेंगे कि in concern with the relativity, how the length is contracted. It is called as length contraction. Then टाइम डायलेशन क्या होता है, और ये दोनों का यूज करते हुए लॉरेंट्स के ट्रांसफॉर्मेशन इक्वेशंस कैसा मोड़ लेते हैं, वो देखना है. सी फ्रेंड्स, length contraction using Lorentz transformation equation. For this purpose, here we are considering a rod which is lying along the x-axis of frame of a reference S. See, now we are familiar with frame of references, the axis x, y, z, the time t. Another frame of reference, as we are well familiar, that is S prime, their coordinates or the axis x prime, y prime, z prime, all these things. Then the coordinates of its ends, the x1 and x2. The length L0 of the rod in the frame of reference S, in which it is at rest, is given in this way. Now see the equation. L0, this is nothing but the length of that rod. x2 minus x1, these are the two ends we are taking its subtraction, equation number 1. Then we are considering another frame of reference, that is S prime, with its x-axis along that of S, and Y and Z axis are parallel to the corresponding axis of S. Let the frame of S moving with a constant velocity v with respect to parallel to the x-axis. Let x1 prime and x2 prime be the coordinates of the ends of the rod as measured in the frame S prime. Very simple thing. Where see, for first frame of reference, that is for S, we are considering the x-axis, that of S, the Y and Z parallel, and here for the S prime we are considering x prime and x2 prime, x1 prime and x2 prime. Then by Lorentz transformations, here these are the equations: x1 prime plus vt prime root of 1 minus v square upon c square, and x2 equal to x2 prime plus vt prime root of 1 minus v square upon c square is same. See, these equations is nothing but from Lorentz transformation equation we have been taking it, and so we here subtracting one from the other, we get this L0. This L0, what is L0? L0 is nothing but the length. Yes, this is the L0, the length of the rod in the frame of reference. Yes, this is a L0. Here we will subtract this equation from this equation, that is x2 minus x1, and by subtracting here we will get here this factor, because here vt prime will get cancelled, and here we will get in this way. Because here it will be the minus sign, and the minus plus minus will be, it will be the yes, and 1 minus x2 prime minus x1 prime root of 1 minus v square upon c square. This will be the third equation. See friends, by definition L equals to x2 minus x1, means length of the rod as measured in the frame S prime, and therefore here you can do this business, that is L0 equal to L upon root of 1 minus v square upon c square, or L equal to L0 root of 1 minus v square upon c square. This is equation 4. It is clear that L is less than L0. L is less than L0. See, once again, this L0 is the length and L is the actual. Hence, for an observer in motion with respect to an object appears to be shorter in the direction of motion than when when it is at rest. It must be noticed that contraction of length takes place only in the direction of motion. Lengths in all directions are unaffected. See once again, lengths in all directions are unaffected, and here contraction of length takes place only in the direction of motion. And means this is nothing a part of relativeness. When a system is in motion, then and then we are getting the contraction in length, and whatever it may be the direction, the lengths are unaffected. This is nothing but the length contraction as per the theory of relativity. Now we will see what about the time dilation. See, in the beginning we have been discussed about the when we are discussing about the theory of relativity. We discussed the relativeness of mass, space and time. Here we will see about a time dilation using Lorentz transformation. Here we are considering a clock at a point x prime, and when c x prime comes, at that time the automatically frame of reference comes s prime. Let s prime be the moving with the velocity v with respect to another frame s along the common x-axis. Let a clock is situated at x. Let this clock give out signals at two instants of time, t1 and t2, as measured by an observer s. Let an observer in s prime measure these instants of time as t prime and t2 prime with his own clock. Then from Lorentz transformation equation for time, see, again these are the Lorentz transformation equations, t1 prime and t2 prime. Again we will do one thing, we will subtract this t1 prime from t2 prime in this way. Means when we are going to subtracting, then this factor will get cancelled, and therefore t2 prime minus t1 prime equal to t2 minus t1 root of 1 minus t square of x square. For the observer in S system, yes, the time interval between the two signals is t0 equals to t2 minus t1. For the observer in the frame S prime, the time interval between the same two signals is t equal to t2 minus t1 prime, t2 prime minus t1 prime. See, for the system S prime. From the above relation that t is larger than t0. Thus, for the moving observer, the time interval appears to be elongated or dilated, and thus t equal to t0 root of 1 minus v square upon c square. This is equation number 3. This phenomenon is called time dilation. See, the time dilation effect is a real effect. All clocks will run slowly for an observer in relative motion. Biological clocks are also subject to this time dilation. Even the growth and decay of living objects are slowed down by this effect. See, in conclusion, which things we have mentioned here is important. This much phenomenon which we have been derived up to here is known as a time dilation. The time dilation effect is a real effect. All clocks will run slow for an observer in relative motion. Means it is in motion with the clock. At that time, the observer observes that all clocks are running slow. And biological clocks are also subject to this time dilation. Even the growth and decay of living objects are slowed down by this effect. In this way, In the theory of relativity, the length contraction and time dilation, these aspects are very important, which are discussed by using Lorentz transformation equations, and it may be asked in the coming examinations, and therefore prepare for all these aspects. Next time we will meet by the next article. Thank you very much.